All right, this is our final exam review, Unit 5. So Unit 5 covered unit circle values. It covered conversion between degrees and radians and vice versa. It covered, what else did it cover? Coterminal angles and just basic right triangle trig. So number 1, draw each angle. Okay, show the direction of rotation. So negative 110 degrees. Okay, it's negative, which means it'll go clockwise. All right, it also means that we have to consider angles going in the opposite direction. So instead of 90 degrees being up here, negative 90 degrees is down here, which means negative 180, negative 270, and back around to 360. All right, so all angles, initial side, positive x-axis. Terminal side, okay, this is negative 110, so it's going to be a little bit past the negative 90. Direction, label. In B, the angle is in radians. So 10 pi over 3. So I want to consider, because that's a pretty good sized angle, I want to consider if it is even bigger than 2 pi. So I'm going to subtract 2 pi. So we'll have to imagine that over 3 using common denominators. So this is really going to be 10 pi over 3 minus 6 pi over 3. So that is 4 pi over 3. All right, now let's consider positive. So I'm going to go in counterclockwise. All right, we talked about unit circle values. This is a unit circle value. If the numerator is 1 more than the denominator for unit circle values, that's pi over 4, pi over 3, pi over 6. So if the numerator 4 is 1 more than the denominator 3, it's in quadrant 3. Okay, and it happens to be close to the negative y-axis. All right, but the issue here is that it went all the way around first, because I was able to subtract 1 full 2 pi. So we go all the way around. And then we go around until we get to that 4 pi over 3. (520 degrees, obviously bigger than 360. So I'm going to subtract 360. Just to see how much greater 520 is. Doing great here. 160 degrees. So remember, we're going counterclockwise, it's positive. So we have our 90 degrees up here, 180, 270, and back around to 360. So 160 degrees is going to fall over here in quadrant 2, fairly close to the x-axis. So initial side. Now, we went 1 full 360 degrees. So I'm going to go all the way around. We know we're going to end up here. All the way around, plus that extra 160 degrees. Okay, negative 19 pi over 6. So this is negative, and it's a fairly big angle, so I'm going to add 2 pi. Again, I want to get a common denominator here. So it's going to be negative 19 pi over 6 plus 12 pi over 6, which is negative 7 pi over 6. All right, now this is still a unit circle value, okay, but it is negative. All right, and that 7 is 1 more than 6. All right, so because it's negative, okay, our pattern goes this direction. So typically, angles in quadrant 2 are 1 less, angles in quadrant 3 are 1 more. But because I'm switching, this one is one less, and that one is one more. But we did go one full rotation around first, and then we went the extra 7 pi over 6. All right, quadrant of the terminal side, and then find the angle between 0 and 2 pi in radians. That's coterminal. All right, so kind of imagine where this angle is. Okay, 19 pi over 3 is quite big. All right, so I'm going to subtract 2 pi. Well, just like the ones I was doing up here, I need to get that common denominator. So that's going to be 3. Which is 13 pi over 3. So that's still too big because 2 pi is 6 pi over 3. So I'm going to subtract again. Well, that's 7 pi over 3. That's still too big because 2 pi is 6 pi over 3. So I'm going to subtract again. All right, so finally we get here. So it's gone around 1, 2, 3 full times, and pi over 3 more. So I'm going to sketch this just so you can see. And pi over 3. All right, so I went around 1, 2, 3 times. So 1, 2, 3, and then the edge, pi over 3. So where did it terminate? It terminated in quadrant 1. What is the coterminal angle that's between 0 and 2 pi? Well, remember, coterminal shares the initial and terminal side. So that happens to be that extra pi over 3. That is your coterminal angle. All right, so we're going to do the same thing with this one. All right, clearly much bigger than 2 pi. I'm going to subtract 2 pi. Get the common denominator. Okay, that's 11 pi over 6. So it's not quite big enough to do one more full rotation, which means I've got my coterminal angle. And if we imagine where this graph ends, we've already talked about this quadrant is one less than your denominator if it's unit circle. This one is one more. And our fourth quadrant is almost double. This one is almost double. So we're terminating in quadrant 4. We go around all the way, and then 1 pi over 6 more. And that 11 pi over 6, that's your coterminal angle. Okay, it has to be between 0 and 2 pi. So that is your coterminal angle. Same terminal and initial side, just different measure. All right, these are in degrees. Same idea that I want to figure out what quadrant this terminal side ends, and I want to find a coterminal angle that is between 0 and 360 degrees. So this one, negative, and I want my coterminal to be in positive. So I'm going to add 360. Luckily, that's a pretty easy add. That's still negative. So we get positive 340 degrees. All right, so when I sketch this, however, we need to be really careful on it because it went one full rotation clockwise. and then it went another negative 20. So it really ended up here in quadrant 4. So we'll go clockwise, and then another 20 degrees. All right, now that coterminal angle, the one that's between 0 and 360 degrees, that's our 340. Remember, it shares the terminal and initial, but it could be a different direction, 340 degrees clockwise. Same terminal initial, different direction. All right, now this one's a pain. All right, 5,125 is just really, really big. All right, so you can 100% subtract 360 degrees as many times as it takes to get an angle between 0 and 360. Find your joy. All right, since I know it's going to be a lot, the first thing I want to do is divide. I want to see how many times 360 goes in, because that's going to tell me the number of full rotations in 5,125. All right, so we get 5,125, we get 14.236. So that tells me there are 14 full rotations. Okay, so that means I'm going to take 5,125 degrees and subtract not just 360, but 14 times 360. And 14 times 360 is 5,040. So when I subtract, I get this 85-degree angle. And that tells me, because 85 is less than 90 degrees, that this angle terminates in quadrant 1, and 85 degrees happens to be my coterminal angle because it is between 0 and 360 degrees with the same terminal and initial side as 5,125. Okay, so this angle is so big, it rotated around 14 full times and then another 85 degrees. All right, draw the angles and find the reference angle in radians for each angle. All right, 8 pi over 3. It's a little bit bigger than 2 pi. And I know that because I've done the over 3s before. Over 3, that was 6 pi over 3. So I'm going to subtract 6 pi over 3 here. Okay, terminal side. Now that's a unit circle value, and its numerator, 2, is 1 less than 3. So this falls in quadrant 2. But it goes all the way around first, and then another 2 pi over 3. Now, as far as its reference angle goes, remember that a reference angle falls between terminal side and the x-axis. So for this angle, our terminal side, our reference angle falls here. That is our reference angle. All right, so how do we get that? Okay, well, that's just less than pi, less than 180 degrees. So I'm going to take pi, and I'm going to subtract 2 pi over 3. All right, well, that's 3 pi over 3. Is pi over 3. I did also tell you with unit circle values, pi over 4, pi over 6, pi over 3, if your denominator ends in one of those three numbers, your reference angle is pi over whatever. This ends in 3, so the reference angle is pi over 3. If it ended in 4, it would be pi over 4. And of course, that's the next one. This ends in 4, so I already know that my reference angle pi over 4, but I'm going to show you how to get that. So we're going to subtract 2 pi. So with common denominator, that's going to give me 11 pi over 4. That's still too big because 8 pi over 4 is 2 pi. So subtract again. So that is 3 pi over 4. Okay, that's one less than the denominator. So we're going to fall in quadrant 2. So it goes around 2 full rotations and then an extra 3 pi over 4. So 1, 2, and then the extra 3 pi over 4. Okay, so reference angle would be pi minus 3 pi over 4. All right, these were TVA values. Okay, so you need your trig, your unit circle for these. All right, you need to know your unit circle. That's not something I'm necessarily going to give you on this final. You need to know your trig values. Okay. So, do this with memory. Cosine 4 pi over 3. All right, well, its reference angle is pi over 3, which means it has an x-coordinate of -1/2 and a y-coordinate of √3. Okay, and how do I know it's negative there? This is quadrant, both negative. This is quadrant 3. Numerator is 1 more than the denominator. Cosine is an x-coordinate. X-coordinate at 4 pi over 3 is -1/2. I'm going to go down instead of left and right because it's going to bother me. Cosecant of 5 pi over 6. So I'm going to start with 5 pi over 6. Okay, numerator is 1 less than denominator, so that's quadrant 2. Okay, 5 pi over 6 has x and y values. √3 over 2, negative, and y value is positive. Cosecant is the reciprocal of sine. Well, sine is the y-coordinate. Y-coordinate for this value is 1/2, and its reciprocal is 2. Tangent 7 pi over 4. This is in quadrant 4. And I know that because 7 is almost double 4. Then it has coordinates √2 over 2. Okay, positive x, negative y. And tangent is y over x. Okay, I did also tell you to know your tangent values. Tangent pi over 6. Negative √3 over 3. Tangent pi over 4. 1. Tangent pi over 3 is √3. You can also remember it, tangent theta is y over x and derive it that way. Okay, so I'm talking about the tangent of 7 pi over 4. Its reference angle tells me the tangent value is 1. Okay, that's determined by the quadrant. In quadrant 4, tangent is negative. Cotangent 3 pi over 4. Okay, that's in quadrant 2. Numerator is 1 less than denominator. So it means its x is negative. Okay, we already talked about. You need to know those 3 tangents. Okay, we're talking about tangent because cotangent is the reciprocal. So the tangent of pi over 4 is 1. Reciprocal of 1 is still 1, and this is going to be negative. All right, so we've got secant of -2 pi over 3. We've talked about when you're going in the other direction with your negative angles, the pattern holds as far as what quadrant, it just flips. So like, since we're going this direction, all right, in quadrant 3, if we're talking about negative angles, things like that, this is when your numerator is 1 less. Quadrant 4, So when it's one more, and quadrant, I'll try that again, quadrant 2, listen to me. And quadrant 4 is when it's almost double. So that means this negative 2 pi over 3 is going to fall in this quadrant. Okay, that means the x is negative and the y is negative. All right, and since it's 2 pi over 3, negative 1/2 negative root 3 over 2. Secant is a reciprocal of cosine. Cosine is an x-coordinate. That's my x-coordinate right here. So I'm going to take its reciprocal. It's negative 2. Okay, I've got sine of negative 7 pi over 6. That's going to fall in quadrant 3. So the x is negative, but the y is positive. So negative root 3 over 2 for the x. Positive 1/2 for the y. Sine is the y-coordinate. Sine negative 7 pi over 6 is positive 1/2. We've got sine of negative 3 pi over 4. All right, this is a negative angle, so I'm going clockwise. And this is one less than the denominator, which means I'm falling here in quadrant. Listen to me write this. This one's quadrant 3. This one's quadrant 2. This one is quadrant 1. We're doing great. All right, anyways, we're in quadrant 3, which means the x and y are both negative, so negative root 2 over 2. And these are all values you're supposed to know. So the sine is going to be the y-coordinate. Secant 2 pi over 3, that goes back to normal, where quadrant 2 is one less. Quadrant 3 is one more. And quadrant 4, almost double. Okay, and this is when I'm going counterclockwise, positive angles. So 2 pi over 3, that's one less. That's quadrant 2. So x is negative. Y is positive. Secant is the reciprocal of cosine. I like how this is the same value. Cosine is x. It's going to be a negative 2. Cosine 7 pi over 6. That's one more, so that's quadrant 3. Which means that x and the y are both positive, or both negative. And the x-coordinate, negative root 3 over 2. All right, if secant theta is negative root 2 and the angle it falls between 0 and pi, then what is theta? All right, so I'm going to start with this, the angle. Secant is the reciprocal of cosine. Okay, and it tells me that the reciprocal of cosine is negative, which means cosine has to be negative. And that's negative in quadrants 2 and 3. But then it tells me my angle has to be between 0 and pi, which is these two. Well, we've already marked this one out. This one's not between 0 and pi, which means our angle is in quadrant 2. Okay, now keeping with this, secant is the reciprocal of cosine. All right, so I'm going to take the reciprocal of secant, so I do cosine. So the reciprocal of negative root 2 is 1 over negative root 2. Rationalize it. So this is negative root 2 over 2. Well, the angle that produces that x-coordinate is 3 pi over 4. Okay, if cosecant is negative 2 root 3 over 3, and your angle falls in, well, that already tells me my angle has to fall in quadrant 4. Between 3 pi over 2 and 2 pi, that's quadrant 4. And cosecant is the reciprocal of sine. So I'm going to do the reciprocal of this. So it's going to flip it over. 3, rationalize. So 3's cancel. And you have negative root 3 over 2. All right, so the angle that produces that y value, because it's sine, is a pi over 3, and in quadrant 4, that's 5 pi over 3, almost double. if sine equals 1 and the angle is between 0 and pi, then theta equals, I had to think about that for a minute. So our angle is between 0 and pi, which sine is positive over quadrants 1 and 2. But if you think about where 1 is, okay, on their unit circle, where the y-coordinate is a 1 is up here. That's pi over 2. All right. If tangent is 1 and your angle falls between 0 and pi, then what is theta? All right, well, tangent is positive in quadrants 1 and 3. Angle has to be between 0 and pi. So that's going to exclude that one, which means our angle has to be in quadrant 1. All right, that was one list of tangent values I told you to memorize. Pi over 6, pi over 4, pi over 3. Tangent pi over 4 is 1. So theta is pi over 4. All right, if cosine theta equals 1/2 and theta is between 3 pi over 2 and 2 pi, this is quadrant 4 automatically, then, right, this is asking for the angle that produces the x-coordinate of 1/2. That is 5 pi over 3. Arc cosine of -1. Okay, this is inverse. This is like saying inverse cosine of -1. So you have to be really careful with this. Cosine is limited to quadrants 1 and 2. So your angles fall between 0 and pi. All right, so it's asking for the angle whose x-coordinate is -1. -1 is there. Your angle is pi. Arc tangent, this is inverse tangent. Well, inverse tangent is limited to quadrants 1 and 4, but a little different. Your angle has to be between negative pi over 2 and positive pi over 2, not including the pi's over 2, because that's undefined there. All right, so I need an angle who gives me a tangent ratio of -√3. That's going to put me in quadrant 4. So I'm talking about the negative angles here. So I'm going to go up and look. √3 was pi over 3. So the inverse tangent of -√3 is negative pi over 3. All right, given this triangle, find the exact value of all 6 trig functions of the value of angle A. When A is 5, so this one's 5, C is 13, that's the hypotenuse. So B is missing. You can use Pythagorean theorem. A squared plus B squared equals C squared. So B is 12. All right, so A is my theta. Cosine is adjacent over hypotenuse. Hypotenuse is always across from the right angle. Always the longest side. 13 is the longest side. So adjacent is 12. Hypotenuse 13. Which automatically gives me secant because it's the reciprocal. Sine is opposite over adjacent or opposite over hypotenuse, so that's 5 over 13. Which automatically gives me cosecant because that's a reciprocal. And tangent, opposite over adjacent, so that's 5 over 12. So cotangent would be the opposite, the reciprocal, 12 over 5. Find the value of each item listed if angle A is 24 degrees and C is 15, which means we know the hypotenuse. Okay, if I know angle A and I know that we have a right angle, then I can find angle B. But either adding them and subtracting from 180 or simply subtracting the 24 from the 90, which is 66 degrees. I'm going to find angle A, or side A first, finding this one. And it really doesn't matter which one you do first. I'm just choosing A. And that side is opposite of the 24 degrees. I have the hypotenuse. I've got sine. Opposite over hypotenuse. So we're going to multiply both sides by 15. Make sure your calculator's in degrees, not radians. So this would be 6.101. Now I'm going to find side B. I'm still going to use the 24 degrees, but this time side B is adjacent. So that's cosine. Adjacent over hypotenuse, multiplied by 15. And there we go. All right, draw out these situations in the correct quadrant and find the values listed. I feel like I might have missed this. Did I remember doing that? I don't remember. Okay, draw out these situations. It says cosine is negative and the angle is between 0 and pi. So that occurs in quadrant 2. So cosine is x over radius. This means I've gone from the origin, I've gone left 3 units. Okay, and my radius, which is the hypotenuse, is 5. And we don't know the y. Can we find the y? Yes, we need Pythagorean theorem. And remember that radius is always positive. So the y is 4. And because it's quadrant 2, the y is going to stay positive 4. So then tangent, which is y over x, would be 4 over negative 3. Cosecant, which is sine, and sine is y over radius, cosecant must be radius over y. So this would be 5 over 4. Okay, tangent is 7 over 24, but this time it's telling you that the angle is between pi and 2 pi. So for tangent to be positive, but to be somewhere down here, x and y would both have to be positive. We're talking quadrant 3. So this is x over y, and since it's both negative, so we're going to go left negative 7, we're going to go down negative 24, and then the radius meets them. Find the radius, x squared plus y squared equals radius squared, so radius is 25. Cosine being x over radius. X is negative 7, radius is 25. Cotangent, well, you can find because we have tangent, take the reciprocal. Convert from degrees to radians. So degrees to radians, multiply your angle by pi over 180 degrees. So degrees cancels. 0 cancels because they were divisible by 10. 3. So we get 17 pi over 6. And then go in the other direction, radians back to degree. Is times 180 over pi. Pi's cancel. 6 goes into 180. 30 times 23 times 30 is 690 degrees. Convert, this is degrees, minutes, seconds. We want decimal degrees. So keep the whole number, keep the degrees. The minute, 27 over 60. Seconds, 10 over 3,600. You would put that all on your calculator. Ignore my emulator here. I forgot what it was. Oh, there it is. 52 plus 27 over 60 10 over 3,600. 52.453. All right, going back the other direction. Whole number is your minutes, or your degrees. We're going to use the decimal. Multiply that by 60 to get the minutes. Because I want the fraction of the minutes, which is 23.1. Take the whole number, and that's your minutes. Then take your decimal, 0.1, multiply by 60 again. This tells you how many seconds out of that minute you still have. 1 times 60 is 6 seconds. Okay, so primarily what's going to happen with graphing, this is unit 6 now. What's going to happen with graphing is you have to identify the amplitude, the period, the phase shift, and the vertical shift, which is also called your midline. There aren't any graphing, so I'm only going to do a couple of these down here because you can use Desmos. Okay. All right, so amplitude and the vertical line are the two easiest ones to find. So if you remember the formula, the parent graph, A is your amplitude. So this number that's sitting in front with multiplication is your amplitude. D is your midline, which is your vertical shift. So that means this plus 3, okay, it means we shifted up 3 units. That means your midline is y equals 3. Period. As long as the B is factored out. It cannot be inside your parentheses. Okay, unfortunately for us, this one's inside of parentheses. All right, so I'm going to put this down here. A little bit of space. So I'm going to factor out, which means I'm dividing 6 pi, or 6 theta, right there. I'm dividing both of these by 6. That's what factoring means. Pi over 6 divided by 6. Okay, that's 6 over 1, so you multiply by the reciprocal. It'll be pi over 36. All right, so then the period, now that I have the B out, 2 pi divided by 6, which is pi over 3. And the C is your phase shift. Opposite of what you think it should be. Minus is right, plus is left. So this is a minus pi over 36. 36. All right, amplitude, 2. Vertical shift, down 3, which means your midline is y equals -3. Period. All right, that means I need to factor out this 1 over 7. That means I'm going to take pi over 7 and 3 pi over 4 and divide them both by 1/7. Okay, for both of these, it means I'm going to multiply by the reciprocal. So multiply that by 7 over 1. So that's theta. I multiply that by 7 over 1. So that is 21 pi over 4. A period, 2 pi divided by the B is 1/7. So this would be 2 pi times 7 over 1. Multiplied by the reciprocal, so that's 14 pi. And then the phase shift is plus, so we're going to the left, 21 pi over 4. Number 3 is out of order just a little bit. It's not bad though. All right, the amplitude is still the number in front of your cosine, but remember it's attached by multiplication. So 1/3 is your amplitude. Your vertical shift is still the number that's floating by itself. It's the 3. So it means we've gone up 3 since it's positive. Makes your midline y equals 3. All right, period and phase shifts, we got to factor out this 3. So that means I'm dividing everything by 3. So for your 2 pi over 3, means we multiply by the reciprocal, which is 1/3. So that's going to give me 2 pi over 9. Period. 2 pi divided by the b. That doesn't simplify, so we leave it alone. Phase shift, that is a plus 2 pi over 9. So that means we've gone left 2 pi over 9. Amplitude, 1/10. Vertical shift, up 3. So your midline is y equals 3. Period, I'm going to factor out a 1/7. So that means I'm taking pi over 4, and I'm going to multiply by the reciprocal. Okay, I'm kind of skipping some steps here. It's the same step that I did on this one. All right, I'm dividing everything through by 1/7. So that means I multiply by the reciprocal, which is 7. And that's going to give me 7 pi over 4. Period, 2 pi divided by 1/7. We've already done that, that's 14 pi. Phase shift, plus, so it's left 7 pi over 4. Okay, so I sketched this one already. This one was kind of 100% a pain to do. Some of the things I want you to be able to find. Amplitude. 1. Period. 2 pi divided by the b. In this case, the b is factored out. It's 1. So that's 2 pi. Midline. Y equals -1, so we should down 1. Phase shift. Left pi over 6. All right, so what you do from here is you get the 5 key points, and I'll explain on number 6 how we get those. So we start with the originals. Then apply your phase shift, and then we graph. Now, remember that you have Desmos. Okay, so I'm going to show you how to graph this in Desmos. Okay, you do have to use x's. Okay, thetas are in there, but they're kind of hard to graph. Then you also want to put the midline, y equals -1. And the reason why you want to put that is because where it intersects, those are key points, those are mids. Remember, sine is high, mid, is mid, low, mid, high, mid, low, mid. Mid, high, mid, low, mid. So each midpoint hits the midline. So as long as your y equals -1 is highlighted, I'm going to see the midlines. My highs and lows, I want to make sure that the sign is highlighted, that it's selected. And then it's going to tell me the peaks and the valleys. And you can use that to determine your graphs. All right, so put your function in the first spot, and then your midline, y equals whatever, in the second spot. All right, so this one we are going to do the full one. Okay, first amplitude is 1, because it's 1 right there. It has been reflected, which means it switches your highs and your lows. My midline is 0. Period. So I'm going to do 2 pi divided by the b, which that's going to give me 4 because you multiply by the reciprocal. Midline, no phase shift, so it stays where it's at. So to get those 5 key points that I told you about, all 5 key points start with 0, non-negotiable. Then you need the rate of change. How does each x change to get to the next piece? Take the period and divide by 4. There's 5 key points. We already have 1 because it's the 0. So the rate of change for the x's is 1. So I'm going to increase each x by 1. So 0, 1, 2, 3, 4. At this point, this is when I would apply the phase shift if there was any, which is what I did here. It was pi over 6, so I subtracted pi over 6. I don't have a phase shift on this one. Awesome. All right, so then we graph. The amplitude being 1 means I can go as high as positive 1 and as low as negative 1. And my midline is y equals 0. All right, now, because it's negative, it switches your highs and your lows. Cosine is supposed to start high. Then we go mid, then we go low, back to mid, high. However, I don't know what color I want to use. The negative switches the highs and the lows, so it starts low, then goes mid, then high, back to mid, back to low. All right, so I'm going to scale. I got 0, 1, 2, 3, 4. So 0 starts low, 1 mid, 2 high, 3 mid, 4 low. Okay, this one was sort of terrible as well. Amplitude, midline, y equals 1. I factor the 2 out, so when I factor that 2 out, we get this. Again, use Desmo, so I'm going to show you that. So I'm getting this. All right, so that means we take, for the period, 2 pi divided by 2, which is pi. Phase shift is right pi over 3, so we're adding pi over 3. Now, all key points start with 0. Our 4 remaining points before the phase shift is you take the period, divide by 4. All right, so the rate of change for all the x's is pi over 4. So each x increases by pi over 4. So 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4. Your last key point should be the period. Then apply the phase shift. You can see why I didn't want to do this with me because we get these over 12s. All right, so, and cosine starts high, mid, low, mid, high. You do have Desmos at your disposal. Remember I showed you on this one. Put in your function in the first box and the midline in the second box. Make sure the midline is highlighted, and that's going to show you your midpoints. You can see how bad these were. If you want to see the highs and lows, make sure the first box is highlighted. Highs and lows. All right, we've got y equals negative 1/2 sine theta plus 2. This theta, this plus 2 is not inside the parentheses. This is your midline. All right, so on my graph, we automatically start at 2. Okay. The period, or the amplitude, 1/2. It is reflected, so it's going to switch your highs and your lows. Period, 2 pi divided by 1, so 2 pi. No phase shift because I don't have any parentheses around that theta. So 5 key points, always go to 0. Take your 2 pi, divided by 4. So there's 4 remaining points. It's pi over 2. So the rate of change for the x's is pi over 2. So each x increases by pi over 2. So pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi. your last key point should be the period. All right, amplitude is 1/2. So if we imagine, let's say 3. Erase that, no. So amplitude is only 1/2, which means I can only go as high as 2.5 and as low as 1.5 with my midline there. All right, sine is supposed to start mid, then it goes high, then it goes mid, then it goes low. But since it's negative, it switches your highs and your lows. So it goes mid, low, mid, high. All right, 1, 2, 3, 4. So pi over 2, pi, 3 pi over 2, 2 pi. All right, 0, we start mid. Pi over 2 is low. Pi is back to mid. 3 pi over 2 is high. And 2 pi over 2 pi is back to mid. Match each function with its corresponding graph. So we got sine, cosine, tangent, cosecant, secant, and cotangent. I always start with sine and cosine because I know those. For sine, mid. This starts on the origin. All right, so I only have one function where it starts on the origin. Okay. So E, sine, which would make the other wave function cosine. And we can see that because it starts at high. Cosecant and secant are the two that I do next. All right, and so if we consider where the peaks and the valleys are. All right, so you see how on cosine, there's a peak on the y-axis, which means on its corresponding graph, there should be a valley. Well, the reciprocal of cosine is secant. So I want to find one of these that has a valley on the y-axis. And I have that here. Okay, you can see that the peaks and valleys correspond with each other on secant and cosine. All right, and then with sine is just the other one to me. The peak is just off of the y-axis. So that means the valley should be just off of the y-axis. And we can see how sine corresponds with cosecant. All right, and that leaves tangent and cotangent. Without any phase shifts, tangent is increasing. Actually, phase shifts have no effect on increasing or decreasing, but tangent's increasing. And so that's got to be C. But the other thing is that I'll always have asymptotes at pi over 2, negative pi over 2, and so on. Whereas cotangent will have secants every pi. So that's 0, pi, and so on. Okay, inverse tangent of negative root 3. So we're talking about these inverses. Sine, cosine, and tangent have restrictions on their domain for inverses. Sine is restricted to quadrants 1, 2, but negative pi over 2 to positive pi over 2. So we have positive reference angles, negative reference angles. Tangent is the same one. The difference is that we don't include negative pi over 2 and positive pi over 2. Because tangent is undefined there. Cosine is quadrants 1 and 2. And it's restricted 0 to pi. Okay, so you have to remember all that. So tangent, negative square root 3. That was among the list of tangents I told you to memorize. All right, where tangent is negative is quadrant 4. And the angle that produces that is negative pi over 3. Cosecant is the reciprocal of sine. So I'm going to reciprocal the 3 over 2 root 3 over 3. We're going to rationalize it. So that'd be 2 times 3, so the 3's are going to cancel. Which means I have the inverse sine of root 3 over 2. Sine is positive, quadrant 1. Okay, the sine of root 3 over 2 is also pi over 3. All right, cosecant of the secant, inverse secant of root 6 over 2. That's not a unit circle value. So if I recognize that secant is the reciprocal of cosine, cosine is x over radius, so this must be radius over x. Okay, it's asking for the cosecant, which is the reciprocal of sine. Well, sine needs y over radius, so cosecant must be radius over y, and you can see that we're missing the y. Okay, so we're going to find the y. So x squared plus y squared equals radius squared. Y squared equals 2, so y equals the square root of 2. All right, well, remember cosecant is radius over y. I've got the radius, which was root 6. I've got the y now, which is root 2. And that does simplify. 2 goes into 6 3 times. Okay, let's go here. That's lovely. All right, secant of the inverse cotangent of 2 root 21 over 21. I don't love that at all. It's fine. Cotangent is x over y. It's the reciprocal of tangent. Secant is reciprocal of cosine, so this is radius over x. So I've got the x. It's the 2 root 21. I just need to get the radius. All right, well, that's Pythagorean theorem. Okay, x squared plus y squared equals radius squared. So this is 4 times 21, so that's 84. I don't know what 21 squared is. I think it's 441. I think that is right. So we're going to square root that. Let me think. So simplify this correctly, and you get radius equals 5 root 21, which I kind of figured would happen because I have the root 21 there. Okay, so then secant is radius over x. We have the radius. We have the x. 21 cancels, so secant is 5/2. Okay, secant of pi. What is pi? Pi is... Secant is a reciprocal of cosine. Okay, I had to think about that. Okay, so secant pi, and you heard me kind of talk it out, is take the reciprocal of secant, which is cosine. Cosine pi is -1, which means secant pi is -1. And the inverse tangent of -1. So remember that inverse tangent is only between -pi/2 and +pi/2. And -1, tangent is negative in quadrant 4. So that's all negative reference angles. So that means this is -pi/4. Okay. Tangent of pi/4 is 1. So inverse cosecant is sine. So where sine is 1 is pi/2. Which means this is pi/2. All right, find each angle. I have pi adjacent over hypotenuse. So we're going to take the inverse. So do that in your calculator. I forgot what it was. 12/13. And you can see it tells me it's 0.3. Oh, I'm in radians. Go to degrees. 22.62. 22.62. All right, we're doing the same thing here. This time we have opposite and adjacent. So I have tangent. We'll do the inverse tangent, 4/13. You see it's 17.103. All right, outside temperature over a day can be modeled using sine or cosine function. Suppose you know the high temperature for the day is 73 degrees and the low temperature is 37, which occurs at 7 a.m. Okay, assuming that the T is the number of hours since midnight, find an equation for the temperature D in terms of T. So I've already written out the equation. All right, for temperature, the easiest one to use is cosine. Okay, because cosine uses highs and lows. We literally have highs and lows. Okay, I just have to figure out whether or not there's a phase shift. So we start by finding the min and the max. And we use the min and the max to find the amplitude and the midline. So the minimum was 37, maximum 73. So the amplitude, max minus min, divided by 2, that's 18. The midline, divided by 2. And that's 55. Okay, now I need the phase shift. Oh, actually, I need the period. The period, guys, this is the day, 24 hours. B is 2 pi divided by that, which is pi over 12. So these are the things that I have. I've got the amplitude, 18. I have the B, pi over 12. I don't know what's going inside the parentheses yet, and I have the d, 55. Okay, the key phrase is here. I have two key phrases. Okay, t is the hours since midnight, and then we have a low that occurs at 7 a.m. Okay, I know that exact time, and that exact time is 5 hours after midnight. So we have shifted to the right 5 hours. So this would be t minus 5. Okay, but I start with a low. Cosine is supposed to start with a high. So to fix that, I make a negative. Okay, that's it.